Okay, so just to reiterate everything you were doing in your homework last night, if we have a negative, then you automatically think of that problem as being rewritten with an I. So every single one of these will have an I. And then what you want to do is break it down into two numbers where one number is the largest perfect square and the other is kind of like what's left behind. So what pretty big perfect square goes into 54? Yeah, 9. So this is like I square root 9 square root 6. Simplify your numerical pieces. What is the square root of 9? 3. So some of you asked if it mattered where the I was. No, it doesn't. It kind of looks gross, but you can write I3 square root 6. In example 2, you automatically bring out an I when you see that negative. So we rewrite it as I square roots of 2. Can I simplify the square root of 2? No. Nope. Okay, bring out your I. What can you rewrite 12 as? 4 and 3. So I heard some of us were going to try to say 6 and 2. Why are 6 and 2 not useful? Not perfect squares. So square root of 4 becomes 2. So you have 2I square roots of 3. Okay, bring out the I in the last example, and you're left with the square root of 36, but we know the square root of 36 is a perfect square. Square root of 36 becomes, so when you have a perfect square, your square root goes away, even with an I. So square root of 36 becomes 6, so you have 6I. Good? Okay, let's look at some with variables mixed in. So I see that negative underneath. I automatically go to the I. What perfect square do I want to use to break into 48? Yeah, the 4 is okay, the 8's okay. The best one is 16. So again, we can think of that as many, many, many square roots all multiplied together. So it's almost like some of the problems we did last night in reverse. Square root of 16 becomes, can't simplify the square root of 3, so that's going to be over here. What about the square root of x squared? There you go. Absolute value of x even turns to odd. And then y cubed, we know all odds leave 1 inside. So that's kind of like turning it to y squared. So 1 comes outside. Yes?
So could you not use 84 or would it just take longer?
It would take longer. You'd have to do 2 square roots. So like, and well, you can't use 8 for any of this because 8 times 4 is 32. So,
86.
yes. So, that's okay. But 8 and 6, like if you simplified the 8, it'd be 2 square roots of 2. But 2 times 6 would turn back into 12. And we know 12 is 4 and 3. So you have to do it again. Yes?
I probably never won the eyes before the 3.
Because I was making the point that the order doesn't matter. I'd say it looks gross, but like the point is that multiplication is commutative, so that's why I even put like the I here. So in the next one, when I did it, I was going to put the I after the variables to kind of prove the point that, like, it doesn't matter where you put the I, as long as the I is not under the square root. So what can we break 18 into? Yeah, so again, you could pick 6 and 3, but they don't get you anywhere. That's okay. I just like bringing up, like, if you did it, you just have to do it more. Okay, square root of 9 becomes square root of a squared becomes absolute value of a. B cubed. We should be getting so good at some of these. Like B cubed pops up all the time. 1b in, 1b out. Tack on your I. The 9 became the 3, so that leaves the 2 and a B.
So the I can go anywhere?
That's my point. Like the I, as long as it's outside, can be anywhere.
I just thought it meant like before or after that number.
It's usually prettiest to put it after the number. That's like where I will write it. But it's not wrong to be here. It's not wrong to be in front.
So I can just leave it at
Yes. Yes. Okay. Next example. Square root 9 x y squared z. So the square root of 9 becomes a... Can I bring anything out from the x? Because the square root of x is just the square root of x because there's nothing to divide. Okay, square root of y squared becomes... And what about the square root of z? So x and c live inside. The 9 became a 3. The y squared became absolute value y. What's this problem not have? An I. Why doesn't it have an I? Negative. Fudge. Okay, how about here? Square root negative 17 R4 S2. Automatically turn your negative into an... Can I multiply or divide 17 by anything? What is 17 called? Prime. R4 will become R squared. Very good. S squared will become perfect. Okay, that kind of summarizes that part. I honestly think today is a little bit easier. So today we almost treat our lesson like adding variables. So if I told you to add 4x to 3x, what's your answer? 7x. Today we're going to add i's together, and we add i's together like you add x's together. If I told you to multiply x times x, you get x squared. So I times I becomes yeah. So, number 1, combine like terms. You are not foiling in number 1. You weren't alone. You weren't alone for my period 1 either. What operation is between the parentheses? Plus sign or minus sign, so you distribute. Exactly. So not FOIL, it is distributive. So you're going to distribute the negative inside. So you get 3 plus 6i minus 4 plus, because a negative times a negative is a positive, 8i. So now combine the numbers to the numbers and the i's to the i's. So 3 minus 4 is 6 plus 8. So now you get 14i. Yes?
So does it matter what figure, right? So I wrote down like 14.
Okay. Technically, complex numbers are supposed to be in the form a plus bi. So, again, addition is commutative, but 90% of my answers, when I write them, will look like this. Just because that's the order of a complex number.
Yeah, I'm just really used to like writing the bigger number. Like,
Technically, the I is smaller, which is why I'd say plus bi, because I is imaginary, so it's the square root of negative 1. So technically, it's smaller, but we won't get into technicalities for that. Number 10, distribute your negative. Group your like terms. So 8 minus 2 is 3 minus 4 would be like negative 1i. 11, distribute your negative. Combine like terms. You get 4 minus 2i. Go ahead.
I thought you did times the three.
So what?
You were 11. Like 7 for like 3 out of 10. I thought you
Okay. Okay, number 12. Is there anything to distribute to my parentheses? No, so they actually just disappear. Combine like terms. And we get 4 minus 3i. So that's the adding and subtracting of the i's. Let's multiply. And this is why I gave you the quizzes I gave you. Because it's so important to understand our powers of I. So yesterday we came up with a list of rules and we said I is I squared is negative 1, I cubed is negative I, and I to the 4 is 1. So anytime I run into a cycle, I'm going to substitute. Today we're primarily going to be focused on the squareds and the cubes. So, just like I said, if you took 3x times 8x, you got 24x squared. Now 3i times 8i is 24i squared. But what is I squared? So you replace the I squared with negative 1, and it's really like negative 24. Is negative 24 a real or a non-real? Is there an I on it? So it's a real number. The I disappears, it becomes real. 12 times 7. I times I squared. I squared is negative 1. So this is negative 84. Number 7. Now we have 3 things being multiplied out. So when I do it, I kind of group 2 together and then tag along the third. So negative I times 7i gives me negative 7i squared. And then I multiply that by 4i. So negative 7 times a positive 4. So negative 28. And I squared times I became I cubed. I cubed is, so a negative times a negative gave me a 28i. 3i and negative 3i would get multiplied together. So a positive times a negative is a I times I is now you kind of have two choices. We can distribute to start, or we can change out the I squareds. So do you want to distribute or change I squared? Okay, so if you change I squared is negative 1. So negative 1 times a negative 9 gives me a now distribute a positive 9 in. 9 times 4 is 9 times negative 4. If you hadn't changed it out and you distributed and then did it, you would still end up with this exact same answer. Because that would have become I squared, so it became positive anyways. That would have been I cubed, and it becomes a negative I. Now, 13 is a little bit tricky. 3i squared does not become 3i squared. It becomes 9i squared. Because 3i quantity squared is really like 3i times 3i. So there's two 3's just like there's two i's. For whatever reason, when we see stuff like that, we tend to rewrite it as 3i squared and not 9i squared. And again, it doesn't matter what order you group it. If you had grouped these two together first, you got 6i squared, then times your 3, giving you 18i cubed. Or if you did 3 times 3, you got 9. 9 times 2 also got you to 18i cubed. But we know I cubed becomes, so this is negative 18i. And again, you could have turned it to a negative 6, and then a negative 18i. There are a lot of ways to get to one final answer. All our final answers need to be the same. So 14 is like 5i, negative 2i, negative 2i. So there's two negatives there. Two negatives make a. 2 times 2 is, so that became 4i squared times 5i. 4 times 5 gave you 20i cubed, which reduces to negative 20i. Last but not least, we can finally do what you wanted to do, which is to FOIL. So you have first, outer, inner, last, combining like terms and trading out I squared, you get 6 minus 26i minus 28. Because I squared became negative 1, so you got negative 28. But now what happens is I have two sets of real numbers, so you get negative 22, negative 26i. One more time. 6 times 4, 24. Negative 18i. Negative 20i. Positive 15i squared. Group. I squared became negative 1 times 15, which is negative 15. 24 minus 15 is 9, minus 38i.